Hello everybody. In this video we will discuss elimination reaction of alcohol. Okay, so we have what type of alcohol is this one? So this one is our tertiary alcohols. So we have a tertiary alcohol, and why this is tertiary alcohol? Well, the carbon atom that is connected to oxygen here, let me draw it out again. So the carbon atom that is connected to oxygen, so this is called alpha carbon atom for alcohol. When it is connected to oxygen and it is connected to three other carbon atoms, so 1, 2, 3. So when it's connected to three other chain, we call that tertiary alcohol. So in this particular case, our tertiary alcohol is being dehydrated. Why it's called dehydrated? Well, water is going out of the reactions. So I could draw this slightly better way to make you a little bit visually better. So you can see here there is a hydrogen. There is a hydrogen. Let me remove this one here as well. So basically what is happening here is the OH and H, they are all going out, and as a result you're making an alkene. So alcohol dehydrated to make an alkene. So let's look at the mechanism. So this reaction has to be done in high temperature and with concentrated sulfuric acid. So if you have concentrated sulfuric acid, so basically what you have here is, so sulfuric acid is not going to be stay by itself. So you have your sulfuric acid. So when you have sulfuric acid in water, basically what you're making is you're making H3O plus. Maybe I should draw out completely. Okay, and you are making SO4 2 minus, because sulfuric acid has two acidic proton, one here, one here. I'm just showing you one example what is happening. So this thing is attacking. So the oxygen has lone pair, and that lone pair will abstract a proton from sulfuric acid, and sulfuric acid has two acidic proton. So basically we can balance this equations by saying something like this. So when you have acid in your reaction, so basically you are making is H3O plus. Now this H3O plus will actually help in dehydrating our alcohol. So let's look at our alcohols here. So we have our tertiary alcohols, CH3, OH, and then that would react with our, so every time you see a positive charge on oxygens, or like here, you want to try to neutralize it somehow. Well, how can you neutralize it? Well, you can neutralize it by releasing this extra proton. So oxygen can be neutralized by releasing this extra proton. But who it's going to absorb? It's alcohol's lucky day. So alcohol would be ready to absorb that proton by its lone pair. Now, if you do that, what is the product that you will be making? Well, you will be making something like this: CH3, 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 and then we have OH. I'm going to color code slightly differently. Now, oxygen has 3 bonds, so it has lost an electrons. So it should have positive charge, right? So three bond positive, 2 bond neutral, 1 bond negative. That's how we have been following our shortcuts. Okay, so again, the rule, so that's plus water, that's the side thing right here. So that's the leftover from here. So now what shall we do? Well, that's our easy solutions, right? So every time you see a positive charge on oxygen, you should try to neutralize it. Now, how can you neutralize it? Well, you can neutralize it a couple of ways. You can neutralize it by releasing the extra proton, either that one or this one. Like, you can bring them back. If you do that, that's basically you're making this product back again. That's why you'll find out all the steps in this reactions are actually in equilibrium with each others. So let's move forward by breaking the bond here. And if we do that, what is the product you think we will be making? We'll be making CH3, CH3, C. Okay, now I just want to a little bit exaggerate. I'm going to show all the hydrogen here for a reason. There is no reason why I'm choosing the CH3 at the bottom to showcase this idea. But you could have done the top one or the bottom one. Okay, so this is a carbocation. Now, what kind of carbocation is this one? Well, this is a tertiary carbocation, right? So we are following the same carbon atom from the beginning. Oh no, we chosen pink color. Okay, I will choose pink color. Okay, so we are following the same carbon atoms. Oh no. Okay, so we are following the same carbon atom from the beginning. So this is a tertiary carbocation. Now at this point, if you're making a secondary carbocation, try to rearrange. Remember carbocation rearrangement? So if you are making a more unstable carbocation, like, and there is an opportunity to make it better, then do it. Make it better. Like you want to make, let's say you have a primary carbocation or secondary carbocation, and by switching it, if you think it's going to be a better carbocation like tertiary, then do it. Then rearrange to create a better carbocation. I will show you a problem in a second. So like 1,2 hydride shift or methyl shift, or 1,2 methyl or alkyl shift. The alkyl shift will happen in the ring structure if there is possibilities. Okay, so this is our tertiary carbocation. Now at this point, what can happen? Well, there is a positive center, and this positive center can be attracted by a nucleophile called, who do we have in our nucleophile? Water. So water could come and attack this positive carbocation. If you do that, that's basically going backwards. So you will make this. So that's why all the steps in this reactions are in equilibrium. So this reaction will go slightly differently. It will favor elimination reaction because we are using high temperature as well. So water will absorb this proton here, and as a result, these two electrons will migrate there. So let me recap again. So water will, well, the oxygen from water will absorb one of the proton from there, from the carbon, to create a double bond. So in this case, CH3, this is a quick step. So whatever you left with is this. So you're going to end up making alkene. So this here, so this is the portion, this is the step where the rate determining step happens. So you have a molecule that's split into two. It's split into this carbocation plus water. right? So it's split it into two things. So it's split it into carbocation plus water. So this is the rate determining step. So in this rate determining step, how many molecules are involved? Well, there is only one molecule is involved. So this is here our rate determining step. So this rate determining step, so this is our rate determining step. And only one molecule is involved. So you see there is only one molecule that's split into two. Only one molecule is involved. So that's our E1 or unimolecular reaction. So E1 reactions. So this particular reactions we call unimolecular reactions. So that's E1, or in simple term, eliminations, unimolecular. Okay. So a few key things in mind are the ease of dehydration. So the ease of dehydrations, like how easy it is to dehydrate an alcohol. Ease of dehydration is tertiary, is the most easy to dehydrate, then secondary, then primary alcohols. Okay. So in the next video, I will give you some of the shortcuts that we have. We'll do some complex problems and I'll give you some shortcuts. Let's stop here.